Hi everyone, my name is Colin, and today I'm talking about how the invasive Himalayan blackberry affects the conditions of the soil it grows in. So chances are, if you have lived anywhere in the Pacific Northwest, you have walked past Himalayan blackberry. The plant is everywhere here. The plant also isn't native. It was introduced in the late 1800s by the famous botanist Luther Burbank, who also imported and bred a bunch of other plants you probably know about, such as the precursor to the russet potato. He also has a bunch of buildings and places named after him, like Luther Burbank Park on Mercer Island. He bred and sold the Himalayan giant, as he called it, for the cultivation of its giant berries. Unfortunately, it escaped cultivation and quickly spread across the Pacific Northwest, with the plant being perfectly fit to thrive in the region's climate. What makes it an invasive species as opposed to just a non-native plant is the fact that it grows rapidly and outcompetes native plants. This photo, figure one on my poster here, is a photo or is a picture I took of a blackberry thicket that I cut a path through. The plants grow thick canes, aka stems or branches, for about 1 to 2 years before dying, thus allowing new blackberry growths to use the dead canes as a base to grow even taller. The thickets can grow up to 6 to 8 feet tall while also shading out and crushing native plants growing nearby. Invasive plants, in addition to killing off native species, can also be known to change the environment around them, especially soil conditions. As Himalayan blackberry is so prevalent in the Pacific Northwest, I wanted to study how it affects the environment. As we already know a fair bit about how invasive plants affect the environment above the ground, I chose to study what effects it has below the soil. I chose to study how the plant affects soil water holding capacity, or WHC, which is a measure of how much water soil can hold and thus make available for plants. A high WHC is considered good because it means more water is available, which can then help plants grow more, help them get through dry spells, and also works to prevent erosion. Over the winter, I completed an internship with the city of Sammamish, working to survey native plants in the city commons park. To do this, I established 23 20-foot by 20-foot plots and recorded the characteristics of native plants. To help answer my research question, I then chose five of these plots from the 23 based on the amount of native and invasive plant coverage they had. Invasive here referring to Himalayan blackberry. These were plots numbers 1, 3, 5, 14, and 20. To measure coverage, I used a quadrat, which is a 10 by 10 grid of PVC pipe and string to determine the percentage of aerial coverage that each type of plant took up. I then took samples from these plots and tested them for water holding capacity. I did this by essentially saturating a 70-gram sample from each plot with water, letting the excess drip out, and reweighing the sample to measure how much water it held. I then repeated this process 3 times total for each plot and averaging the results. Based on how invasive species usually negatively affect their environment, I hypothesized that a higher invasive presence would correlate to a lower water holding capacity, and a higher native presence would correlate to a higher water holding capacity. All right, my results. First, I looked at each plot's invasive blackberry coverage and compared it to their WHC. This graph shows the results with plots arranged by invasive coverage in the blue bars in a descending order. Plot 14 had the highest percentage of invasive coverage, followed by plot 3, then plot 1, while plots 20 and 5 didn't have any invasive plants present. The red bars show the soil water holding capacity as a percentage of each sample's total weight. Looking from left to right, it initially looks like plots with a higher invasive coverage have a higher WHC, but then plots 20 and 5 mess this trend up. I then thought that if invasive coverage doesn't correlate to WHC, what about native plant coverage? Unfortunately for my hypothesis, native coverage is even less correlated to WHC than invasive. This graph is arranged similarly to the previous, in which the plots are arranged left to right by descending native coverage. Plot 20 has the highest native coverage, followed by 5, etc., etc. This really got me thinking if neither invasive or native coverage correlates to changes in WHC by themselves, what would happen if I combine them? I then combined the invasive and native plant coverage to get a measure of each plot's total plant coverage, then compared that to each plot's WHC. As with the previous graphs, this shows the plots arranged in descending order of total plant coverage. Unlike the previous graphs, this graph shows that as a total Where am I going? I apologize. Zoom gave me a notification that I stopped recording and I wasn't. Um, unlike the previous graphs, this graph shows that as total coverage increases, so does the WHC. This is a super cool result as it tells us that, in essence, the soil doesn't care if it has invasive or native plants growing in it. It only cares about having more plants. So, why is this? My study didn't examine this, but one main driver of WHC is the amount of organic material in the soil. If we assume that increasing the total presence of plants also increases the amount of organic material entering the soil, like from dead or dying plants, dropped leaves, roots, etc., then it would make sense that having a higher total plant coverage would result in a higher WHC. These results also leave a lot more to be studied. Studying other qualities of soil, such as microorganism populations, nutrient levels, pH, soil chemistry, and more, are important to get a bigger picture of how invasive species change soil conditions. My study was pretty limited due to my time and budget, but more extensive studies could reveal a whole lot more. So, what do we do with this information? Well, it seems that Himalayan blackberry on its own doesn't change WHC, but it's still an invasive species. Blackberry often outcompetes native plants and establishes monoculture stands, where it's the only plant growing in an area. Reduction in biodiversity can be very harmful for native ecosystems and for both native plants and animals alike. While it seems like increasing total plant coverage has generally positive effects, restoration workers should seek to build up that coverage with native plants as they bring a number of other ecological benefits with them. Furthermore, the effective removal of invasive blackberry should be prioritized. Himalayan blackberry is an incredibly resilient plant. If you remove a plant, you have to cut the canes to lengths of no longer than 6 to 8 inches long, as an entire thicket can resprout from a cane longer than that length left touching the soil. Furthermore, the roots of the blackberry plant also have to be completely removed, as they can resprout as well. Himalayan blackberry is also capable of a process called layering, in which, if a growing cane touches the ground, it can sprout new roots in the soil. Now, there are several different ways to remove a bunch of blackberries in a short period of time. The first is to use graze animals like goats. Goats are capable of eating most parts of a blackberry plant, including the thorns, which makes them very good at eating through a thicket. The downside to goats is that they won't get the roots underground, allowing the blackberries to regrow after a while. And they're also not selective eaters. So if you have native plants still growing in the blackberry thickets, they'll get chomped up too. Another method of removal, and the one I recommend, is hosting volunteer events. Humans are a lot better at identifying plants than goats, and we can choose which plants to remove or keep. During my internship in Sammamish, I ran a volunteer event in the plots I was surveying, and as shown by the before and after photos of figures 5 and 6, it was extremely effective. While inexperienced volunteers can sometimes remove native plants, with enough guidance and preparation, this can be avoided. Furthermore, as most people volunteer in areas close to where they live, hosting volunteer events can be a great way to get people involved with the care of their local environments, work together with their neighbors' community, and increase the general public awareness of the dangers of invasive species. Thank you all for listening to my ramblings, and I hope that I've left you all with a lot to think about. I want to thank my supervisor during my internship, Sebastian Ritako, for his patience and mentorship, as well as my advisor, Eli Wheat, for his advice and knowledge. I also want to thank my family for their continued love and support. Thank you.